What if we don't have this global declaration? What would happen? What would happen? If we don't have the global declaration, first of all, notice that the spider here, all right, does not flag any error. It seems like it's okay. But there's a bit of a danger, all right? So far, it is okay and probably will not have any effects. Let's run and see. Let's compare the outcome. Everything is exactly the same. Notice that? Okay. But that is very dangerous. It's like dangerous driving. Hey, my hands is off the steering wheel and it's still okay. I'm running at 100 kilometers per hour. Look, it's fine. I'm sure you agree it's fine, but not safe, right? Yeah, it's unlikely the car will suddenly steer, but there's always a chance, and this chance has been greatly magnified if you don't have your hands on the steering wheel. Same thing here. Here, by default, if we don't have a global declaration of a definition of a variable name, when we first reference it, of course, there is no local definition of tax deduction. There isn't any. So tax deduction can be local, can be global. When we first reference it, there is no local definition of tax deduction. So Python searches upwards and finds a tax deduction in the global space. Henceforth, from here on, all right, the tax deduction scope will be global. We can refer to it many times and it will be always 100, 100, 100. So we do see this. Now there seems no problem with it. But if, however, this profit adjust changes or wants to change because of new taxation year, it's no longer a deduction of 100 but $200. So your profit adjust twiddles or modifies something in the global space, and then using that value, you continue your calculation. Again, spider here doesn't sense anything that's wrong. There's no red flag. When we run it, okay, what happens now is that Python detects that you have created a variable name called deduction, all right, that you intend to set as 200. But remember, anytime we create a new variable name by assigning to it, it becomes localized. So although you think you are trying to modify the global container, it is actually a quiet local copy that happens to have the same name called tax deduction that has been created and stored with the value 200. And now you refer to this local version of tax deduction, not the global version. And when you exit, you see that here when we ask, what is tax deduction variable in the global space? No change, right? Because you didn't change it. That's the problem. So when you try to uh, do what you think is right here in terms of the global local thing by not declaring, all right, carefully what is the scope of your variable references inside, that would be a big problem. So now we again declare that all references of tax deduction in our function here, all read and write refer to the global space tax deduction. Then you'll find that yes, inside the function, everything is about 200 because the local scoped tax deduction just now overshadows the global variable. So everything behaves like as if it's okay, but when you exit, to our horror, tax deduction wasn't changed, right? If you intend to change the global variable tax deduction, then you need to declare using the global keyword. And now you're operating directly. There's no extra copy called that text deduction created. No uh, duplicated references. Everything is pointing back to the global copy. Okay. So this is very important to get right the first time because we don't really want to delve on it for too long, confusing ourselves with local, global, and all that. Suffice it that you are aware that all variable names inside a function are local unless being declared as global. As a shortcut, if you don't declare global, you may just quietly reference global, so long as you don't assign anything, create any local, use any local assignments that happen to have the same name as the global. Then you may just directly reference the global variable. All right, that is a shortcut, and that can be very nice because it seems the right thing to do, or it can be very disastrous, as in the example I've just shown you. All right, as a sort of rule of thumb, it is frowned upon, not nice. All right, totally not appreciated that a function changes the global value directly. Not appreciated, not encouraged. You'll be marked down, you'll be failing, you'll be given a big cross and all that. Now we do see some very decent high quality codes that actually do that, but they kind of restrict that forbidden kind of coding, like directly changing global variable values inside function. They restrict that to only a very small code space, so everything that needs to be hacked upon are done there, and then the rest are all following general high quality good programming guidelines. So there are exceptions, but of course you're learning now, so I want you to keep in mind that as a general rule, all right, definitely tell yourself if you're trying to modify a global variable within the function, wrong thing to do. There has to be a better way, and there is always a better way, right? Don't modify global variables inside the function. Okay, good. So back to our slide, our classroom here. We see that basically this is what we have discussed earlier on. We also have seen the default value mechanism, which is very cool because it allows us to kind of like not having to say the obvious, the default values, the standard parameters when it's not needed. So the function can continue with some basic standard values. We call them the default values. Now, there is this idea of uh, local variables being put inside the parentheses, as we have seen here, right? We kind of use it, but now let me bring your attention to it. These are local variables, no difference from the little x here. These local variables therefore disappear whenever the function ends and reappears again when you have a next call to profit adjust, and disappears again and reappears again and disappears again. All right, they are always local in nature. We call these special local variables up in the parentheses parameters. Parameters. So we tend to say the parameters of the function are profit and amount. Or don't please don't define so many parameters in your function. So that's what we are talking about. Or to be more explicit, we call them the input parameters. Now obviously they are always input. Okay, the column must supply a value to each and every input parameter except those with default values. Then it becomes optional, or it becomes named input parameter. So the profit that we see here is a positional input parameter, meaning your first number to profit adjust is always given to profit. It's always because profit is position number 0 and your x value here is position number 0. Okay. If you put amount to be, for example, 100 instead of 1000, so let's remove the extra line here. What happens? Notice first of all, Python Spider didn't flag any red flag, and notice that our amount has been modified, overwritten to the new input value. Okay, so the amount here acts like also a positional parameter, because the first number goes to profit, the second number goes to amount. Okay. However, it is also additionally possible to use the amount parameter as a named input parameter. So we can say, spell in exactly the same way, amount is equal to 100. So what this does is that Python will first look at X, finds the first input parameter because it's position of 0 match to 0, 1 match to 1. And then all the named parameters can be anyhow positioned. They can be rearranged in any order so long as you name all of them. But if you don't name all of them, then stick to the position all through. You cannot have a sort of a mix in between. You can have positional values first. Once that is all done, then you have all the chain of named values behind, and the named values can be in any order. All right, so it can be amount first, amount last, doesn't matter. So because the name is clear, it's unambiguous. And here, when we run this, we should see the same result, no change at all, because we are very clear in specifying that the input parameter that's called AMT is to be changed or set with 100 from whatever value it has. So far, so good. Now, all named parameters will have to have some default values. So if we need to have another input parameters, percentage, okay, it cannot be left as it is. We can say that the percentage can be by default 100%. Okay, so then we can say this profit minus amount, and then multiply by percentage divided by 100. Okay, so by default it's 100%. So if you don't specify it's 100 over 100, it's no change to X. So if we run this, it's fine. It's fine, yeah, because it's just times 1. But if we were to say, let me just purposely have a different sequence. If we were to say percent is 50%. Okay, so now notice two things. I have inserted a new parameter, all right, and I have reordered the named parameters. So amount, even though it's declared in the function as being first before percentage, when you call it, the caller has the freedom to anyhow order the named input parameters. So when we do this, we know that the value of X is going to be halved because of the percentage adjustment to half of it. And the parameter passing has been beautifully, conveniently, and unambiguously done, right? Again, imagine the fact that profit adjust wasn't written by you, it's by your teammate. And the teammate just says that, oh, you know what, if you need to scale the resulting difference, just give me a PRC percentage. Will do. And if you don't, there'll be no adjustment. So we see how useful that was, right? So if you don't input PRC, then nothing changes because it's times 1. And whether it's times 1 or if you check if PRC equals to 100, then return nothing and so on, that's very local to the function. Your teammate has full decision right to decide how to implement that code, and that doesn't affect us so long as the result behaves the way it is being defined.